طيب بسم الله الرحمن الرحيم. وأصلي وسلم على أشرف الخلق أجمعين سيدنا محمد صلى الله عليه وسلم. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. So in this session, let me explain the principle of the fast packet switching or asynchronous transfer mode shortly. Here we are talking of statistical multiplexer, StatMax, which can offer certain quality of services guarantees. So we are saying that statistical multiplexer, which can offer certain quality service guarantees, or what's called QoS. Now we assume that these M sources or M traffic sources have the data or the traffic which are statistical in nature. So they are statistical in nature. So they do not transmit a constant periodic bit rate, but their bit rates are variable in nature, and that is where we will show that there is an advantage of statistical multiplexing. If indeed all these users are transmitting at a constant bit rates, then we know that multi-rate circuit switching or circuit switching may be considered as more efficient. So we're saying that these M sources or these M traffic sources are statistical in nature. Their bit rates are varying, and let us assume that their bit rate can be characterized by some kind of probability density function, or what's called PDF. Here is this statistical multiplexer, and here have these M sources are there. Now these source or these sources are statistical in nature, and they will transmit it on this output link. So we're saying that each of these traffic sources are statistical in nature, and therefore their bit rates can be characterized by some kind of PDF, and that how it looks like. So here is a source whose the traffic characteristics may be represented by this density function. We are, of course, assuming that the traffic sources is statistical or stationary in nature, and this is the density function of this bit rate. So now what we're saying, here is the traffic sources. Each of these traffic sources are characterized by this kind of probability density function. So now we are saying that when these sources are multiplexed, whether we can have some kind of admission control, which can offer you quality of service guarantees. So let us represent these bit rates of these individual sources by, say, R1, R2, and so on up to Rm. So what we are saying is that this R1 plus R2 plus dots plus Rn is equal to Y, where Y is the output bitrate. Now, each of these R1, R2, and so on, till to Rm, each of these bitrates are varying. They are statistical in nature, and the density function of each of these are Ri, which we denote by this function, shown to be something look like this. So we can say that this is probability density function of a source whose bitrate in this case is Ri. Now our problem is that these different sources are statistically multiplexed over here, and here is the output bitrate Y, and we may ask this question, that if these sources have to be multiplexed, and if the multiplexed bitrate becomes Y, then what is the probability that there may be a certain packet loss or delay? So we will just review that, how to offer quality of service guarantees in such scenario, and that will be shown inshallah in the upcoming video. So till now, stay tuned and see you soon. Thank you very much for listening.